Hi there, I wanted to talk a little bit about jump point search tonight. So, if you've ever worked on writing a game, or you've at least had aspirations to write a game, one problem you've likely encountered is pathfinding, and how do you handle it? Well, one of the most common algorithms for working with pathfinding is the venerable A-star algorithm. It's a real classic in computer science. It's very general, and it's a really great algorithm to work with. However, if you're like me, you might be a little bit surprised to know that while A-star has been around for quite some time, that there have actually been advancements in pathfinding for specific cases in even, say, the last 10 to 15 years. And one of the most notable ones there is the jump point search algorithm. Now, what's special about jump point search? Well, jump point search is actually quite a bit faster than A star for a specific type of map. If you can put some constraints on it, you can say, hey, we're working on a square grid. Um, if the cost to step from any one given square to the next one is the same, that is, you don't have like mountain or water or anything like that where you're trying to model a higher cost between the different grid squares. Uh, if you can have those particular restrictions on your map, jump point search may be a good fit for you. And as you can see, it's several times faster, so there's an advantage to be had here. Now, how does it manage to do this? Well, very roughly, it's able to take into account some of the symmetry that occurs, and it deals with these ideas of forced neighbors. Now, there are many details to this. There are certain pieces of it that can be a bit complex. I encourage you to take a look at it. The purpose of this video is to discuss a few of the practical considerations that I ran into along the way when trying to actually use jump point search within my code. Now, if you're like me, you also maybe have encountered that when you try to use a library from somebody else, that library may not always be a perfect fit. You might find that your interfaces don't line up, or certainly with something like pathfinding, maybe your notion of passability or obstacles needs to become a little bit more complex. So you can either create, a complex wrapper around that library, or you can look at potentially re-implementing it. In my case, I thought it made sense to re-implement it, and hey, why not? Computer scientists love to re-implement things, even even if they introduce their own new bugs and whatnot. So during that re-implementation, I did find a few practical considerations I wanted to look at, and so I wanted to walk through some of those with you. So one of the first things that I encountered in looking at this is that if you look at the output of jump point search, it doesn't give you every grid square that you walk over. Rather, it gives you the jump points. So there's sort of, you can look at the details, but in some ways you could think about it as where you need to change direction, and that you can interpolate between those from jump point to jump point. Well, the trick there is that if you're working on, something where you have a path that may have an obstacle get inserted into it, and you want to monitor for changes, you've got a little bit different scenario there. And so in order to be able to handle that type of situation, I needed to interpolate between the jump points to handle monitoring on a per block basis. That way, for example, I could say, oh, I've looked up a path. Here's all the grid squares that it touches. Now I'll keep like a hash set of some sort of those. And if uh, the obstacle or passability of something changes, I can look and see if it affects any of my currently open paths, and I can go and check it out and change it as needed. And so I just had a little bit of code that did the interpolation there. It's not too much. It probably makes sense to just look at how you would implement that in your own code. Another issue that I ran into is how to handle portals. Well, if you look at the different types of passability that I am sort of representing, the classical ones here might be out of bounds, passable, and obstacle. I've got two other ones in here, portal and partially passable. We won't talk about partially passable at this time here yet, but we will talk about portal. So portal is the idea that within one local room, I have a square that represents an outbound link to another room. And so there'd be a number of different ways, a number of different conventions that you could use to handle this. But the way that I chose to handle it is that, generally speaking, unless I want to actually pass through that portal to someplace else, I really don't want my NPCs or anything else walking through that portal. Now, that may not be the same restrictions on your game, but that seemed to be a reasonable set of restrictions on here. And so, as you can see, I needed to change some of uh, my tests for forced and passable. And the way that I chose to do this is I would pass in the goal, and as long as my current point wasn't both the goal and a portal, in which case I would sort of make a special exception and say that it was passable, or that it was not forced in this case, then I would treat it, largely as an obstacle. And so just wanted to share that adaptation as well. Maybe you'll find that that aligns with your situation, maybe not. Just a note on that. For the portals that are inbound, I would just drop the character onto that, and the destination room of that portal wouldn't really be aware that there was even a portal pointing to it. It would be fairly agnostic of that. Uh, Other types of things that need to be careful about. Well, as you can see, unsurprisingly, we've got a uh, global pathfinder and a local pathfinder. I just broke that down where local pathfinder is within the room and global pathfinder is between rooms. There's again a variety of different things you may want to take into consideration there, but that's just how I broke down the classes that I have. Now, one thing that I wasn't really aware of at this point that I just needed some education on was how to handle distance. So somewhere along here, you're going to either need to calculate distance between 2 points, or you're going to potentially want to estimate the distance between 2 points for heuristics, especially if you're looking at global path finding for using a star at a global pathfinding level and then jump point search and a local pathfinding level. So you're going to want to consider distance. Now, if you've got 2 points on a grid, it's true you can use Euclidean distance, but if you think about how jump point search actually navigates, you're only going on, up, down, left, right, but you can also go on the diagonals. And you can't just go on arbitrary angles on this. And so your Euclidean distance, basically your your squares, your sum of squares, square rooted, that's not really going to work that well here. If you're familiar with Manhattan distance or city block distance, in theory you could use that as well, but it's still not really the best fit. Probably the distance metric that you want to use is one that I wasn't familiar with. That's octile distance. The friend of all game programmers here, Amit, has an excellent little write-up on it. It's just another simple distance metric that you can use, and basically it considers the diagonal distances and the vertical and horizontal distances. That was another adaptation. Now within this, I'm writing in C#. I like working in C#, but sometimes its collections aren't as nice as they could be, and I found that there is an additional set of collections that you can use in the C5 libraries, and in particular I found that the heap was useful, as well as I think I ended up using the hash linked list for the individual nodes. At any rate, a lot of their collections are useful because they also give you events to monitor on when the collection changed. And that's something that I found that was particularly important to work with. Now, one other adaptation that I made, going back to our passability types here, was this partially passable. I ran into an interesting conundrum in working with the game where, in some sense, uh, I have this grand ambition that my entire uh, game's world is going to be loaded at any one given time. But most of it is going to be running headless, as it were. And the NPCs are actually going to be walking around within it and fairly complex. We'll see if it actually pans out. But that's the idea. Now, in order to be able to do that, obviously, if you're loading the whole game sort of into memory on the backside, you really don't want to load things you don't need to. And one of the things that I didn't really want to load was enough information to do per pixel obstacle checks. So an a balance that I found on this is that I would store the grid, and for the most part I would say that things are passable or obstacle, but I would also take into account anything that's like, oh, I don't know, say a piece of furniture or something like that, and I would mark it as partially passable. And what that would do is, from an NPC's perspective and from a pathfinding perspective, it isn't really passable in the normal sense. So it doesn't really participate in the pathfinding, but having that differentiation allows for when my character is actually running around, I can do the more expensive pixel check right at my character's space, and that allows them to go into partial squares. So if you've got, say, for example, a furniture, a couch or something that takes up half of a square, it will allow the character to go halfway into it, do the expensive pixel check, and say, well, you need to stop now. Whereas the NPC just has to go all the way around it. And I think that that's a reasonable balance to find, but just trying to think about how you can practically make it work. Now, within this, certainly I can't underestimate the power of unit tests for something like this. It's very, very unit testable. I found this excellent site here that allowed me to build up some of my unit tests, and I was able to work through some local Pathfinder unit tests. I like to store my map representations in ASCII and test a variety of different situations, making sure that it could hit all the different points, etc. And I had a number of global Pathfinder tests as well. At any rate, those are some of the adaptations that I found to be particularly useful as I was trying to practically implement jump point search, and I wish you the best of luck in your journey as well. Thanks.